Hello, welcome. Let's have the continuation. This happened to be episode 33 by the beginning of the discussions on momentum and impulse. So let's have a recap of the laws of Newton, that which we make use of under equations of what? Motion. So we are going to just look at the logs, just a recap of that. The first law says that to every body, so everybody continues in each state of rest or in each uniform motion in a straight line unless acted on or compelled by what? External force. So if a body is in motion, it will continue to move in motion until there is an external force acting on it to stop. Or a body also continue to be at rest always until external force is acted on it or compel it to move. That is the first law of what? Newton's motion. Then number two, which is basically the center of this episode, is what? The time rate of change of momentum of a body is directly proportional to the applied force in the direction of the force. So the time rate of change of momentum. Momentum is just the momentum of a body is the product of its mass, the product of the mass of the body and its velocity when it is still in what? Motion. So here we are only saying that the time rate of change of that momentum of the body is directly proportional to the applied force, which is all going to be in the direction of that applied force, which is kicking of ball, collision of bodies, cars in motion, propelling of what? Bullet from a gun. They are all using the mass and each word velocity in consideration. Then the last one is the action and reactions of any body are equal and what? Opposite. So if body A and B are having forces acting on each other, the forces are going to be equal and opposite to what? Each other. So if we can delve into it more, we can say that the momentum as mathematically can be represented by what? The mass of the body times its what? Velocity, which is the momentum equals to mv, mass and velocity. Let's see a body which is moving with initial velocity and end up with a final velocity within a given time. We can also talk about the initial momentum to be equals to the mass of the body times its initial what? Velocity, which will be the mass and u being initial velocity. Then we can also find its final momentum. That is also going to be the mass of the body and the final velocity, which is actually the definition we had in the beginning. Now, if the bodies are going to be in motion, and with time, we can also know that there will be a change of that momentum along the way. There will be a change of momentum. So we can also say change of momentum will also be equals to the final momentum minus what? The initial what? Momentum. We can deal with this as what? The change in what? Momentum. As we have a final velocity and the body remain the same. So the mass will be the same. Therefore, we can easily say that the mass factorized out, we are going to have what? V minus what? U, as in the change in what? Momentum. Now, if we can bring to light the second Newton's law, which we can write down mathematically, we can also make use of this. So from here, let's delve into the second law of motion, writing it mathematically and see how we can draw a connection between that and what? Impulse. So we can see that mathematically we can express the second law of motion mathematically as if we are saying the force is directly proportional to the change in what? Momentum over the time taken to act. So remember, the change in momentum, we can have this as m, then we have our mv minus what? Mu divided by what? T, mathematically. The change in momentum which we have here. So we can still remember that this is taken as this. So we can have this as mv minus what? U divided by what? T. Now, this is a constant of what? Proportionality, which the definition says. So we can just say if this is taken as force equals to, let's say this is alpha. I think this proportionality, let me rewrite this as, how will I write alpha? Okay, the alpha times what? Okay, let me just use K so that it will be easy. K M V minus U divided by what? T. Now, but this we are seeing here, I can also say that, but our V minus U divided by T is what? Acceleration from the laws of motion that we have. So this here can now become F equals to K, M, and what? A. Now remember that a force is a Newton. So if a force is in Newton, it's just talking about the force needed to act on or to move a body 1 kilogram of a mass with an acceleration of 1 meter per second. So if we are dealing with that, the acceleration of this is 1 and this is 1, the force is 1, meaning the K become what? 1. So that will just give us the F is equals to what? MA. So if that is mean that we are having that, we can come back and say F is equals to MA, which is V minus U divided by what? T, in order to eliminate the constant of proportionality, making use of that K to be equals to what? 1 by the definition. The proportionality, we are using force is a Newton. It's just a force needed to move 1 kilogram of a body by an acceleration of what? 1 meter per second. So in that section, we can easily say our constant of proportionality become what? 1. Then this is going to be what we have. So from here, if we cross multiply, then Ft will now be equals to mv minus what? U. This is what gives us the definition for what? The impulse, the time effect on a force. This is the time effect on a force is equals to the change in what? Momentum. Or better still, the impulse is just going to be the product of the force exerted and the time it takes to act. The product of what? The force exerted on a body and the time that body takes to act give you the impulse. So this is the impulse, which is also equals to the change in what? Momentum. So this can be taken or drive us further if we want to deal with the principles of conservation of what? Linear momentum. I will reserve that for the next episode, whereby we just take the definition for this as an impulse and take 1 or 2 examples to end this episode. So that in the next episode, we deal with the principles of the conservation of what? A linear momentum. So right from here, we can say that where our Ft is what? The impulse. Or we can just say what? Time effect of a force, right? So the time effect of a force. So if we want to define the impulse in 2 ways, the first one will be the definition of this, the product of force and time. So that's going to be the product of force exerted on a body and the time it's what? At. As in just the FT product. The force exerted times the time that it takes to act. That is what we can call the impulse. Or better still, we can define it based on the right hand side, which we can say that impulse. Okay, so by the two definitions, we can either define it as the product of the force exerted and the time it acts, or simple put, change in momentum of the body is the impulse or force on that body. I guess the two definitions are stem from this side. All right. Now, if we are asked to find the momentum of any body, all we need to know is the mass of the body, the acceleration. We multiply together, then we can get to know that particular momentum. Let's see, for example, we have to find the momentum of a car with a mass of 250 kg and moving with a velocity of what? 100 meter per second. So if you are doing this, we know momentum is going to be the mass of the body times what? The velocity. And the mass is 250. The velocity is what? 100. And that gives us 25000 newtons what? Seconds. Or better still, kilometer per what? Seconds. All right. So this is just to know how to find momentum. Then when we move to the episode 34, then we delve into the conservation principles. There, the calculations of collision of bodies, either they are having elastic nature or inelastic nature. That is where we start with all those calculations. Don't forget to come back for that episode. Like, share, comment, and subscribe.